Hello, everyone, and welcome to Plants to Plants, the cannabis processing talks. This is our episode 2 of our 2024 season, and I am absolutely thrilled to be joined today by Zev Feinstein of Molecular Forces. He is a collaborator with us at SciPhy Systems to bring out a brand new product, the hydrocarbon membrane system, HMS. This joint product between Molecular Forces and SciPhy is a first of kind to the market, applying membrane separation technologies to butane and propane. It is worth saying that Zev is by far one of our most popular prior guests from his episode back in 2021 about the X-spiral membrane systems, which provide separations for ethanol and heavy hydrocarbons. Now being able to apply the same technology to propane and butane is really going to take us forward in the market to brand new capabilities and enhanced efficiency. So Zev, can you tell us a little bit about yourself, introduce yourself, and then let's get into how we came from the heavy hydrocarbon applications to our compressed gas applications today.
Yeah, so I'm Zev Feinstein. If guests might know me from my previous appearance here from my company Molecular Forces Consulting, my membrane product X-Spiral, or my contributions online and on Instagram as Magister Chemist. I have been deploying membrane products since 2020, initially for, like Emmett said, alcohols and heavy hydrocarbons, but a longstanding goal of this product had been to convert the applications already developed for heavy hydrocarbons to light hydrocarbons. It was well known from prior data that alkanes tend to act similarly. A separation heptane is likely to work well in pentane, for instance, and it was expected this trend would continue onward in butane and propane, but there was a significant complication in that those are compressed solvents that only stay liquid in a closed loop environment. And a great challenge with membranes is that once they have been wetted with a solvent, they must stay wetted. And if they evaporate, they lose much of their separating power. So it was difficult to achieve in an R&D setup a situation where we could be completely confident that our compressed solvents would never decompress and allow the solvent to evaporate off of the membrane surface. Eventually, that challenge was overcome, and these solutions were validated on the R&D level. This was followed by an engineered product with numerous safety features and valves to prevent any possibility of inadvertent evaporation in the system, ensuring the membranes stay wetted and cannot become de-wetted. Now that that's a deployed product, we are free to pursue all the application data directly in butane and propane. And we've developed some SOPs already that show extreme promise in both cost cutting and product quality improvement.
Absolutely. It's really a thrilling time to be able to apply these and get real data on how cost performance is increased, and also just consistency of quality. I really think that this product could change the standard operating procedures for extraction in a propane or butane extraction system substantially, and only to the benefit of both ease and cost of manufacturing. So I know that the X-spiral products in ethanol and heavy hydrocarbons, we have a dewaxing and color remediation type of technique, as well as a solvent recovery membrane setup. What's the difference between those applications and what we've been able to prove out so far in the butane and propane applications?
So as I was saying, essentially, this takes the techniques already developed and deployed in large scale with heptane and pentane-based plants. It's quite different from ethanol, but very, very similar to the alkane applications that had already been developed. The main difference with this product, we are offering 2 classes of membranes currently. One is a unified dewax and decolor that does both of those functions simultaneously. And what this does is it allows warm extracted oil, once it's passed through this membrane, to have quality equal or superior to cold extracted and CRC'd oil from the same derived biomass. The other function is an HTE separation membrane. These membranes can reject a significantly large portion of cannabinoids while terpenes tend to freely permeate through them. What this allows is for us to cut a fraction if you're using a tight membrane where most of the cannabinoids were rejected while almost all of the terpenes came through, yielding a product very similar to what's called HTE when it's separated by conventional methods, high terpene extract.
Right. So we have a single stage dewaxing and decoloring system that allows you to run warm, so no longer needing to go down to -70, -40. Even the potential here is to run close to room temperature or at room temperature, and then use the membrane to remove all the color bodies and waxes that typically are picked up in that warmer extraction, and have a pure output with a very high yield. You don't see loss really in this system. And that is extremely exciting for eliminating very heavy chiller loads. We've been performing a lot of energy audits and assisting clients in doing applications for energy incentives, just looking at how much energy is being used by chillers just to chill solvent, and in some cases for folks that are chilling their extraction columns using chillers as well. That load is huge. So we're talking about potentially millions of kilowatt hours of savings using this type of system, and that translates to real cost savings over the lifetime of this equipment. Even in year one, you're talking about at minimum thousands of dollars, maybe tens of thousands of dollars of savings for larger scale operations. So that's very exciting. What can you tell us about, the output quality coming from the dewaxing and decoloring stage? I know that one concern people have with using media, such as, CRC media or granular media, is that it has some impact on the flavor profile, terpene profile. What does the membrane, refined oil look like and smell like on the output?
Yeah, so of course it's all going to depend on the biomass input still, even with this kind of a filtration. But the primary concern people have with the CRC media is that they tend to be acidic or have active sites on them that can lead to isomerization of terpenes, or can tend to absorb certain terpenes, either decreasing the total amount of terpenes, changing them to new ones, changing their proportions to alter the overall character. These are all things that lead to the characteristic, difference between a CRC treated oil and an oil that was, extracted cold and well, but not CRC'd. The great thing about these membranes is, first of all, they're a purely physical separation. There is no active site on them that has any possibility to cause any conversion. Furthermore, they, as I said, let terpenes through at a much faster and easier rate than they do the cannabinoids. So as opposed to reducing the amount of terpenes in the end product, you're actually going to see an enhancement, because so much garbage, so much wax and color bodies have been removed, while the terpenes freely permeate the dewax stage, let alone the HTE stage.
Right.
And what we find is when you have passed it through the dewax membrane, the smell of the permeated oil is almost always, superior to what people had been getting using the same biomass in their old process. Great fruity odors, great lack of the one note effect often seen with CRC.
Right. So this approach, rather than creating a sort of CRC oil or that bleached oil type of fragrance profile that sometimes becomes uniform across even different batches, or you see sort of a bias towards that. This instead is much more preserving the original terpene profile, the original flavor fragrance profile of the biomass, and giving you a more accurate reflection of the original flavor and fragrance, which is always the target, especially for high-end oil production. So whereas CRC and media largely have allowed people to improve what might be lower grade oil into a moderate grade oil, in this case, using these membranes really can make even higher grade oil, even top shelf, even better than it would be, and still give those benefits of improved color and reduced wax. So that's an extremely valuable value proposition, and really differentiates it from the capabilities of using media. Moving on, this brings us to the other function that's we have out as of today. Right now, the manufacture of HTE or high terpene oil extracts is quite labor intensive. You're talking about sweating oil, doing crashes, that type of thing. In this case, you're performing a straight through separation, bringing terpenes over, and then preserving that profile to be able to use as a terpene concentrate. What is the specification that people can expect from this separation? I mean, is it somewhat equivalent to like a diamond sauce type of composition, or is it different?
Well, as you know, we were lucky enough to have a willing partner who contributed a good amount of materials to this project with the goal of getting an HTE in the first pass below 30% total active cannabinoids. That was easily achieved, and data bears out the fact that if you run repeated passes, the cannabinoids will continue to decrease proportionally. Mm-hmm. But we have never seen a total active cannabinoid above 30% in these HTEs, regardless of what kind of feed has been employed so far.
Right, and so that means that you're getting a flowable, mixable HTE out that really works quite well as a flavoring additive into things like vape carts, or even as a way to reformulate oil. The other big application I think that we've seen demand for is actually taking those lights off to improve the prospect of diamond mining, essentially, that we're reducing what needs to be removed to produce a THC isolate, or even, I suppose, a CBD-A or CBD isolate as well. Is that fair to say?
I do know that the Dewax function has been known to be highly useful in allowing for an easier crash of cannabinoids, even though many people thought that they needed to use CRC to get an easily crashing system. We saw many spontaneous crashes of cannabinoids isolates when using membrane-based Dewax, even when we were running into heavier hydrocarbons like heptane and pentane, and that trend has continued with butane and propane.
Yeah. Which, I think right now there's a big question in the field. Previously, the whole concept of liquid diamonds or decarbed isolate as a base for vape carts was perhaps seen as a luxury category or a novelty. The question remains now, is it actually potentially cost beneficial and cost advantageous of creating a high cannabinoid output oil that doesn't have terpenes, and decarbing it, adding the terpene or HTE back in and using that as a vape cart? I think we've seen that pretty broadly being applied in the so-called live resin vape cart space, whether they're publicly saying that that's what they're doing or not. But this ability to use membranes to at least get a large percentage of that work done up front really opens up the opportunities to scaling that approach and to bringing the cost down, because your labor expenses are very low.
Yeah, you could spin it a few different ways. One could easily do it by running both membranes. You run the Dewax membrane and get, a live resin type product. You run the HTE and get the terpenes separated off of that live resin. The live resin could then be decarbed and used as a stock for vapes remixed back with the terpenes, or the terpenes could be mixed with, another oil like distillate. There's many ways, that you could put these products back together and get a vapeable solution like that.
Right. I think one question people are going to have, since we brought up live resin, is how does this system perform in that fresh frozen application? And specifically, we mentioned earlier that running warm for extraction. I think it's probably fair to say that we're going to see less reduction in the temperature in the live resin application because water is still a concern. Is that true?
Yeah, so when you're running live resin, of course, we all know you can't really run room temperature because the water content is so high that it's going to cause many poorly understood phenomena later on in the extraction process. So I would recommend, when I recommend people running cured material, I say you don't need to chill at all. Just run it at room temperature with your chillers, completely shut off. But I wouldn't go so far as to say that with the live resin, because you're going to need to still keep the water locked up. And that doesn't require temperatures any lower than 0 fundamentally. You need a safety buffer, so perhaps a few degrees below 0. With the membranes, you want to run them as warm as you can, because there's no benefit in going colder because you're going to be removing the stuff using the membranes. And there is a cost associated with going colder, which is that these membranes, their flux depends on the viscosity of what they're fed with, and the viscosity always goes up as the temperature goes down. So you see a linear rate decrease in how much you can put through the membranes the colder you get.
Right. So you actually want to run these membranes at the warmer temperature in order to get your maximum throughput performance. Now, that said, it's worth looking at what the throughput rate is on these membranes and seeing how that might fit with different operations. Yeah, what can you tell us about the throughput rating on the 2 different operations we have?
Both of the operations right now, according to SOP, are specified with a rate of 10 pounds per minute of oily butane solution passing through the membrane, either for the Dewax or the HT membrane. 2 different membranes, but their speeds are very close. This is, of course, speeds at room temperature. The speed will be different if you purposely go to a low temperature, and it's going to be dependent on what that temperature is.
Right. So 10 pounds per minute, that's quite a fast rate. Looking at our extraction, products or extractors, that is a rate that could match potentially, you're talking maybe 50 pounds an hour of extraction, or maybe, more or less depending on your solvent ratio to your biomass, of course. So that's quite a bit of throughput capacity just using a single membrane. It is worth mentioning that the hardware is capable of running more than 1 membrane. So if you need to expand beyond that capacity, you can double it by adding an additional membrane housing if you're one of those really powerhouse large-scale operations. But for small-scale operators that see that rate and are thinking that's a little bit large for their production capacity, how would they work this into their workflow if they're, say, extracting 10 pounds an hour or something like that?
So this raises an important point that needs to be talked about, which is that unlike the X spiral with liquid solvents, where we have a solvent recovery membrane, we don't have that product here for butane yet. So they still are going to be running their recovery the conventional way, sending the permeate from the membrane into their recovery tank, evaporating the solvent off and recovering it using their standard active or passive recovery. Since that still needs to be done, that still is going to end up being the time limiting factor for these smaller systems, and it's actually essential that you always pick the membrane to have a greater throughput than the recovery does, because once you've started running the membrane and it started feeding into the recovery pot, you can run recovery at the same time that you're running the membrane filtration. If the membrane was slower than your recovery, then you'd be bottlenecked by the membrane because you'd finish the recovery and still have solvent trickling in there, when you would have been done with a regular run. What you need to do is have the system be a higher throughput than your recovery so that the amount of time you've already blocked off per run to run recovery will have been enough time for all of the fluid to pass through the membrane into the recovery tank, thus, not extending your time per run beyond what you were used to before.
Sure. Although for those operators that are used to using a sort of honeypot technique of stacking runs, it is worth noting that the system has an optional tank skid that comes with it that would allow you to sort of stack those batches and then meter that solution into your solvent recovery. So if you wanted to run a bunch of runs, run filtration, save that dewaxed solution in a tank and then feed it gradually into your solvent recovery because you do have a bottleneck at solvent recovery, that's completely feasible. Also, is it, for people that are running these smaller runs, is there a turn down ratio? How would they adapt the membrane to their relatively lower flow rates?
I mean, you can turn down the rate of the membrane simply by reducing the applied pressure. The throughput is linear with pressure, so if you turn down the pressure to a quarter of what the SOP says, then you get a quarter of the rates. But I don't see that as being helpful or necessary for most people because, again, you're not going to have a problem with running the membrane too fast. It has no effect on the quality. All that's going to happen is that you're going to get everything in your recovery tank and be able to start recovering everything all the faster. If you could run it through the membrane system in 1 second, that would be optimal. Then you're definitely not bottlenecking anything. So I don't think that there's such a thing as too fast. There could be something too fast in the sense of I bought more membranes than I needed, but that's not the case here because you're running one membrane. There's no smaller size than the 10 pound per minute size.
Right. And so from the controls perspective, really you're running, as I understand it, with the Dewax, you're concentrating the wax in the feed tank, and then you're permeating over the cannabinoids into whatever the receiving vessel is, if that's your solvent recovery vessel, or if there's some other surge tank like would be on the tank skid that we provide. Are you just running it until you get down to a certain weight or a certain level in the tank to measure concentration? Tell people a little bit about the actual hands-on with the equipment.
Yeah, so it's going to differ a little bit depending on whether you're running the Dewax function or the HTE function naturally. But the pattern is you do your extraction just the way you normally would, except with the modifications for temperature, etc., that we already discussed. Then everything will be fed, like you're saying, into the auxiliary tank that is used to recirculate fluid through the membranes. And if you're running the HTE membrane, you're going to be sending over to recovery a solution that is primarily just terpenes with a small amount of cannabinoids in it. And you're going to be running recovery on that. While meanwhile, the cannabinoids are actually being solvent recovered in a sense, since the solvent is leaving along with the terpenes. You can draw it down until those cannabinoids, their oil portion, is at a 1-to-1 ratio with butane, at which point it's pourable, as people are used to pouring that ratio of oil for diamonds already. With the Dewax function, it's run quite similarly, except in this case the cannabinoids are coming through along with the terpenes, along with the solvent, all going to recovery. And what you're ending up with in the circulation tank is not a 1-to-1 of oil to solvent, but rather a 1-to-1 of your rejected fats and pigments to solvent. And that is essentially a waste product.
Right. I know that in the hemp industry, some people have tried to valorize those waxes and do things like using them in skin care products and things like that. Maybe as the industry continues to develop, we'll see that come over to the recreational and medical side as well. But as of right now, that waste product probably is just going to be rejected to waste. And if you want to put it in a larger vessel and pull vacuum on it to recover some of the solvent down, you can do that. There's a variety of ways to handle that waste. You could potentially pour it out. However that feels right in your SOP to deal with that, you would do that. In the case where they want to run both Dewax first and decolor, all Dewax decolor one stage, and then the HTE separation second. I guess really what we're talking about is just sending the cannabinoid-rich oil that's been dewaxed, or the cannabinoid-rich tincture that's been dewaxed, over to a tank, whatever that tank is. Could be solvent recovery, it could be a separate auxiliary tank, and then either clearing the recirculation tank you're using for Dewax and bringing back over that solution to then be recirculated again. Or it could be configured that your auxiliary tank is valved so that it can become your feed recirculation tank for the membrane itself. And so you just keep those tanks completely separate from each other and reduce the chance of any sort of cross-contamination or anything like that. So there's a little flexibility there based on how much space people have, how many tanks did you already have, and it can be as compact as possible, using as few tanks as possible, or be a completely staged out, batch-wise operation. But either way, at the end, you have a very, a quite dilute butane or propane and terpenes fraction, and then your concentrated cannabinoid fraction, and then from the first stage you have a sort of concentrated wax and color. And so that's really pretty familiar to people that have been running Dewax columns in their in their butane extract. Although that's gone a little bit out of fashion, some people are still running it. But this is sort of like bringing back the advantages that had, without any of the difficulty, without the extra filler, without the low temperatures, with the energy. And really, because you can pour out the waxes, you have a lot more flexibility in terms of how you are going to deal with them. Because I know a lot of people hated having to deal with the filter plates or fritted dip or whatever they were using to catch the waxes and dewaxing columns. So this just gets rid of that concern entirely.
Yeah, if you want, if somebody who was used to running it in that old-fashioned, way wanted to have a comparison, you could imagine the scenario where you had extracted warm and then passed something to the Dewax column and only then began to chill it in the Dewax column. Naturally, even compared to what you were used to seeing in the Dewax column, you'd see a greater portions of fat falling out, because those people who were running the Dewax column also were running a initial cold extraction that prevented pickup of some of the waxes in the first place, whereas we're talking about picking up the total full spectrum and then excluding stuff later. But I want to be very clear with everybody that this system only does one function at a time. It can't do both functions at once. So when I spoke earlier about it won't extend the time any, because it as long as your recovery is slower than your filtration, the recovery is still going to be the rate limiting step. That claim only really applies to if you're running one function, because if you're running two functions, you have to do the first function entirely, and only then can you start recovering when you're running the second function.
Although it's worth noting, if we're just talking about purely extending timelines, that running the HTE separation is by far faster than any of the other terpene separation approaches that people are using. So you're going to get to a finished HTE and terp-free oil product, in 10% of the time of what you would be doing if you were trying to, do a crash or some other, terpene separation technique.
Yeah, and there's also some other factors that bring your time down when you use this product. You're not necessarily running through CRC, which, especially with people using powdered medias, has often extended timelines quite a bit. You're not running a Dewax column whose SOPs often involved a significant dwell time. And also, you're not needing to heat your solvent back up to from -70 up to boiling point and then chill it back down from boiling point to -70. Since you already started at room temperature or close to room temperature, your recovery is actually going to run all the faster because you're not spending a bunch of time just heating the solvent back up. It's pretty much ready to recover and at temp the moment it goes into the recovery tank.
Right. Amazing. So many advantages here. So let's talk a little bit about how people might integrate this product into their existing setups. We have a 2-component offering right now with the membrane filtration skid on its own caster frame, and then a tank skid that is optional for those that need additional auxiliary tanks just to drop it in and start using it right off the bat. It's got all the valving, everything that you need to integrate those two and just have it be a standalone operation with ins and outs to your existing system. So, what does it look like for an operator that has an extractor and wants to bring this in to their process? Is it really just, are we talking flex hoses, or are we talking, hard piping it in? What do you anticipate that looking like?
Yeah, so the recommended approach is using our tank skid, but we've left the option open for people who want to supply their own tanks, just because there's many people in the market now who have an abundance of deconstructed equipment that could yield, very similar tanks to the ones we're supplying. It connects essentially in line between where your extraction column is and where your recovery tank is. If you imagine a simplified closed loop that just passes from extraction directly to recovery, this would go in between. The extraction will go into the circulation tank. So you need that as one additional tank that could be supplied by you or by us. That is the tank that is going to hold the fluid that's running through the membrane. It's that tank is what's going to end up with the retentate or reject portion, while the permeate or the portion that's been dewaxed is going to go into your recovery tank. Mm-hmm. So it's sliding in between there. And then the tank skid includes a second tank that just holds some clean solvent for the purpose of cleaning the membrane end of run or end of day. Like the X spiral, you want to make sure that when you turn off the system at the end of the day that it's sitting in clean solvent, not in wax.
Right. And, by default in our design, we're offering quick connects for the interconnection between the tank skid and the membrane skid, and also as an option from the membrane skid to your upstream and downstream. That also could be provided as compression fittings or potentially tri-clamps if people requested that as a custom order. So we can accommodate people's existing systems with how it needs to be built to fit in. Obviously, the quick connects have their advantages of making it very easy to install, and if things need to be moved, doing that. Looking forward, I think it's worth mentioning some people may have space constraints that make this difficult to implement. We think it's absolutely worth adding to your control area space in order to gain this capability. But just with a forward-looking statement, we're talking with people in the field about what the best way to reduce footprint or help to integrate this technology with other existing systems. So if you're concerned about space in your facility and want to give us some feedback about what it would look like to help reduce the footprint and bring it into your space, please email us. You can find our contact info at www.sciphysystems.com. You can email me at emmettm@sciphysystems.com. And we'd love to work with you to find a way. We're considering something like a vertical orientation system. However, We know that in states like California, Oregon, and others, there are seismic requirements that mean that we would have to work around how to permanently, bolt this system into either the frame of an existing system, to the walls, to the floor, something like that. So we really want to hear your input on what you think the best way to improve the footprint is for your specific operation.
And of course, one of the main reasons why I worked and continue to work with SciPhy is because they have had a lot of experience in doing these full service installs. My work in Xbarrow was more devoted towards a, generic deployable product on wheels that could be slid in and installed with, very little support. Whereas SciPhy, is very used to coming in, even doing welding and piping themselves, modifying configurations on a custom level, so that we've come with an abundance of resources thanks to our collaboration to help with a project of that sort. Naturally, everybody's probably worked in at least one place where they felt like the booth wasn't even big enough for the extractor they already bought, let alone trying to put more equipment in the space. Hopefully, if you've been through a few installs, people are making that mistake less and less, but almost everything in the system could be even wall mounted in a totally deconstructed format if that was what was necessary to get it to work. Just make sure that if you're reaching out about this product and you're really concerned about these constraints, like I don't even have space to walk around my extractor hardly, that we know that from the earliest points so that we can make it work nonetheless.
Right. Yeah, in some cases that will necessitate adding additional C1D1 space, which we can certainly work with you on that basis. We're familiar with working with people from facilities design all the way through product implementation and integration. So as Zev just said, we're glad to work with people on their specific projects, and by far the advantages are worth it. I just think it's worth reiterating that, the media savings alone from Dewax, you could be talking about 5% improvement on your cost of manufacturing, maybe even more. You're reducing your labor substantially. The power savings that you're going to get, again, on our calculations, you're looking at potentially millions of kilowatts a year in savings, which is thousands of dollars in savings. So this product will pay for itself easily over the lifetime of your equipment. And another huge thing is it in a lot of cases will make it so that you can run more runs in a day by increasing your effective throughput capacity, so long as your solvent recovery system can keep up with the filtration side of the system. So eliminating that color remediation bottleneck, and also the terpene separation bottleneck downstream could be a game changer for a lot of operations. So in the development of the HMS, there was a unique challenge with dealing with compressed gases like butane and propane, in that there were concerns around the membrane life and keeping the membrane safe in operation. What can you tell us about that and how we overcome those challenges?
Well, one of the main questions when we were setting the system up is, generally speaking, you run the permeate over to zero pressure when you're running a liquid solvent. You run a high drive pressure as high as 800 psi, but the output pressure of the permeate is just going out into a bucket at 0 psi. That's the way it runs in ethanol, and that's an approach that doesn't work for butane, because if you run the permeate with no restrictions on it, what you're going to have is there's high pressure liquid on one side, and as it goes over the membrane, it flash evaporates through the membrane layers, actually yielding a completely different separation process called pervaporation. And in our very first trials, we ran it in this manner, getting completely different results from what was expected to happen. I knew that would be likely to be the case, but but it might have been a result that was beneficial. We couldn't know until we tried. To keep it wet, what we've done is apply a purposeful restriction on the permeate that is applying 30 psi of back pressure, keeping the permeate liquid so that there's always liquid on both sides of the membrane and there's no chance of any flash evaporation going on.
Mhm.
And as could be expected from theory, the permeate ends up coming out in a manner much more similar to what we saw in pentane, hexane, and heptane than when we were allowing it to freely evaporate, where we were getting a result that was quite different.
Right, and in fact, it just essentially wasn't effective unless you were able to keep it liquid on both sides of the membrane, on the high pressure side and on the permeate side.
Yeah.
For those that are using propane or other high pressure solvents, does the pressure of the tank that the solution is going into on the permeate side affect the operation of the membrane?
If you're running propane, then naturally the permeate tank would have a higher pressure. If your intention is to run propane, it would be best if we simply substituted a higher back pressure valve for the one I was describing, 30 psi. We might substitute that for 60 psi if you were running propane to make sure it stays liquefied.
Right.
The result is going to be quite minimal. The result is going to be a proportional decrease in the throughput rate because you're looking at a pressure differential now of, say, 600 to 60 instead of 600 to 30. But that difference is so minimal compared to the much, much bigger effect, which is that propane has a smaller viscosity than butane, which is an effect that increases the rate vastly in excess to that small proportional decrease coming from the differential pressure change. Because all alkanes have a trend where they decrease in viscosity the smaller they get, and it's a very linear trend. Heptane is twice as viscous as pentane, and thus it runs at half the speed. Now, pentane is twice as viscous as propane, and it runs at half the speed. And you can interpolate butane and hexane into that linear sheet and see where it's coming out. And that's proven to be almost exactly correct for every one of these solvents. So if you just chart the viscosity versus the throughput rate at a given pressure.
Right. And so I think that actually hints at one of the other key innovations that we have here. People will see that there are actually 2 pumps on the HMS kit instead of 1, like you might see on an X spiral. I know that we have also a clean solvent tank specified on our tanks kit. So what can you tell us about what that's actually doing and how it improves the process?
Yeah, so there's 2 purposes for the clean solvent tank. One is just to clean the membrane end of day, like I was saying, or end of your, runs. But the other purpose is when you're running the Dewax, these membranes have a non-zero inherent cannabinoid rejection, which means if you ran all the fluid through the membrane, or all the fluid minus the dwell volume through the membrane, you'd still have some cannabinoids left over. And the second pump can be used to add some fluid directly into the circulation tank as you're getting down to the end of the run there to continue to extend the run time, add more solvent, and flush through any cannabinoids that might be remaining. This is called diafiltration. If you've run the X spirals, you're already likely familiar with this process because it's used in the color remediation SOPs, whether you're running alkanes or alcohols. But the difference being, since everything's done in an essentially open system in those, there was no need to supply a new tank or a new pump because it could be added manually or with any old pump. Since everything's closed looped now, it was necessary to also close loop the diafiltration function. That said, considerable improvements have been made in reducing the amount of diafiltration volume for the Dewax, and it's not necessary at all for the HDE because you're actually trying to hold the cannabinoids back, not push them through.
Right. So this just gives you the flexibility to really maximize your yield out of the dewaxing stage. And it should be a relatively minimal addition of solvent. for those that are trying to hit 99.9 yield or something like that, which we don't advise that. I think that there's diminishing returns on time at a certain point. But you can add more solvent into the loop while it's running in order to really push through any last remaining cannabinoids in the system. And as I've mentioned, also having a fresh solvent tank on board here with all the appropriate valving lets us flush the lines in between operations. So that means if you're running Dewax and you're running the HTE separation, you can flush the wax out of the system in between operations and then have a clean system when you switch your valves over to the HTE membrane and run that separate batch HTE separation run on the skin.
Yeah, that's a really good point that I hadn't even thought to bring up, but that's also a very fundamental use of the clean solvent. Now, somebody's probably going to ask the question, well, why can't you just push all of the fluid through the membrane? And the reason you can't do that is because the lines hold volume. The tube that contains the membrane holds some volume. There's a non-zero hold-up volume of the system, a liter or two of fluid. And because the membrane has to stay wetted, you have to allow that hold-up volume to just be there. And that's why you can never get 100% through, because, you're going to be just diafiltering this set volume, and you're going to approach 100% but never reach 100%. It's a little different from a CRC column in that way, because you're not just passing everything through and leaving everything dry in a dead end. You're running a membrane that has to stay wetted.
Right. So that's a key point to emphasize here, is that the system, the membranes must always be in contact with solvent, even while they're in storage. So the system has to be closed loop, has to be pressure rated to contain that solution in the membrane housings. Of course, the membrane housings are seeing 800 PSI or up to 800 PSI during operation, so they're well rated to contain the solvent. That's not an issue, but that's another reason why the permeate side has to be pressurized as well, is because those salts have to be wet, even when storage not operating.
Yeah, if we hadn't, even aside from the concerns with pervaporation, if we didn't add that valve on the permeate side, what you'd see is a slow evaporation once you turn the system off, where everything eventually bubbles through the permeate side, and the hold-up volume evaporates, which would be which would hurt the membrane's effectiveness. Thankfully, you don't really need to worry about these things, because they've all been taken into account in the design considerations.
Right. It comes to you safe to operate, safe to store. It'll contain the pressure it needs to keep liquid in the filtration housings. And but that was a part of the design challenge, and we're very thrilled with the results of the final design. So let's talk a little bit about what comes next. I know X-Spiral is still seeing some improvements. I imagine HMS is going to continue to see membrane research coming into the fore. What can you tell us about what comes next in development and what people can look forward to?
Yeah, so there's a few projects going on right now that are of interest. One is the possibility of filtering oil directly through the membrane, because the only reason you can't just put oil through the membrane is because oil is, it's oil. It's so thick it can't really be pumped. But that's not the case for all oils. HTE is a free-flowing fluid that can be pumped and pressurized, and so you can put HTE directly through these membranes and get a Dewax done on it that way without even needing to use any solvent. This has already been done and tested, and has results, and even has throughput numbers attached to it. We haven't deployed a system in the field for that purpose, but I'm very excited to, and this could be of value if you're somebody who's, like certain people I met, has had, thousands of pounds of unsellable HT locked up that they couldn't figure out a way to increase the quality on without losing terpenes in the process. Now this is a solution for that issue.
And so essentially what that lower quality HD looks like, is that just cloud point and it's not low enough viscosity, or what are people looking at that they could improve here?
HD that's very dark has a lot of pigments, or HDE that is, like you said, cloudy, thicker, has some wax. Since the membrane does both dewax and decolor, you can pass through dark oil, cloudy oil, have it coming out, very clear and yellow.
Yeah.
I believe I've posted some of this on my Instagram already, but
that's very interesting. Of course, there's concern when you talk about holdup volume. Of course, that becomes a real concern when you're dealing directly with the oil without any dilution. So I imagine this is a potential new product that'll be designed specifically for very low holdup volumes in order to make that.
Since it's not a closed loop product, since it's not holding solvent pressure, it's really more of an X spiral type application, but it is another very exciting way to monetize HDE. Another project perhaps that is more relevant here, there is a currently ongoing project to produce self-contained units that essentially have their own fume hood built onto them. That's going to be deployed fairly soon for X spiral, and as soon as the designs are finished for the X spiral version of that, it's also going to be sent back for iterations on the HDE. And if that's the case, it's going to be a great solution for people whose booths are too small, because you essentially just need to duct lines from one booth to another in a compliant manner, and everything else is already, fine. It's rated inside of a box that is its own hazard area.
Right. So this is a plug and play system where it'll come with a existing enclosure, and you duct it and you tie in power, and I suppose there'll be some questions about how the piping will come in and out, and that'll depend on the facility to facility basis, how you interconnect this system with others, but making it so much faster to implement. I mean, I think everybody that's brought in a new C1D1 or C1D2 booth and has realized the premium on the floor space and the amount of time that it gets to actually get those things fully implemented will appreciate having something that is just drop it in and get running. Obviously, you still have to do the tie-ins. So you got to deal with contractors no matter what, but it'll certainly reduce the burden.
Since this, it's going to be designed in such a way that you could even use a plug with it, because the plug-in would be outside of the hazard zone by definition. There's naturally some cost increases that come with attaching this extra hardware, but I believe that they will prove to be much smaller than the amount of money saved in installation costs once this product is priced and on the market.
Excellent. That's really thrilling, and especially once we get to the HMS, which stay posted for updates. Just a little plug here at SciPhy Systems on Instagram and all other social media, sciphysystems.com. Also, molecularforceslc.com.
molecularforceslc.com, and my Instagram at Magister Chemist.
Excellent. Yeah, so stay posted. That will be very exciting, especially I think for the operations struggling to find the floor space to implement this new and well worth it equipment to dramatically reduce your cost of manufacturing. In fact, why don't we talk now a little bit about who the ideal customer is for the HMS system. I think we've hinted at what the applications are here, what the advantages are, but I think giving a real profile for people that should be looking at this right now and basically having very little hesitation about bringing it in to their operations would be helpful. Number one is if people are running CRC or granular media on every run they do, pretty ideal candidate, right? Yeah, I think we've seen some operations where we did a financial analysis hand in hand with a client, and they're using even tens of thousands of dollars of medias on their oil, even a week. That is, this system pays for itself almost instantaneously if you're using that much media, right? And if you're specialized in running those dark oils to light oils and you're running heavy production, I mean, this is a no-brainer. It will save you money starting day one. The other folks that I would really urge to consider this type of technology is high-end operations and people focused on producing top shelf oil.
Yeah. Naturally, since one of the main benefits of this technology is cost saving, if you're having trouble producing oil for the correct cost and the driver of your cost is CRC or amount of energy used for chilling or inability to get enough runs in the day because of either CRC or chilling, these are things where this will be a big reducer of your cost per gram. And it only will proportionally increase because the cost of adding extra membranes is not very high compared to the setup cost, and it's not a chronically repeating cost in the same way CRC is. So the larger your system is, the larger the savings you're going to achieve with this system are. This system can get quite a lot larger than 10 pounds per hour without a proportional increase in the cost it takes to install it.
Mm-hmm.
And get
so
that size.
Basically, if you have one dedicated operation that you're using HMS for, you could readily quadruple the throughput capacity of that operation very straightforwardly. It's just a matter of modularly adding housings, and we can work hand in hand with you to make sure that that installation goes flawlessly. So if you're looking at this as a starting place and you're really aiming for the stars in terms of scale, you want to be ready for federal markets, or if you're in the hemp business and you're really already scaled to a national or international market, this is a solution that you can rely on to expand with your business moving forward.
Yeah, and if you've inherited equipment designed for truly industrial level processing, you've probably already run into severe issues trying to extend these CRC methods that were designed for small batch runs up to, the capacity of running thousands of pounds a day, and you're probably already banging your head against a wall in a way that, the system is designed to alleviate.
Right. And again, leaning towards the high-end products at those large scale operations, oftentimes there will be sacrifices made that prevent those operators from approaching a really high-end product. With this type of technology, because you're preserving all the terpenes, you're reducing the time of operation to get this color reduction and wax reduction. And also, especially for HTE and high terpene fraction manufacturing, you can actually at scale produce top shelf product with an HMS in a way that it's really almost cost prohibitive to do at scale otherwise. Again, a big driver here is you don't have to chill your solvent down to those very low temperatures, which is time consuming and energy intensive. And then the color remediation Dewax will readily keep up with the rest of your system without bottlenecking it. So that's a huge advantage for, again, operators that are really trying to scale for big states, operators focused on a scale into national level, or even if you're just trying to grow your market share to a large percentage in a state where there's market share to be had. I'm looking at you, New York. I'm looking at also even up and comers like Ohio that have relatively large populations. I truly feel the first people to implement this technology in some of these emerging states are going to have an almost unbeatable advantage when it comes to mass producing high quality oil that will be very difficult for people to otherwise, do cost effectively.
Yeah, I agree with all that. As we already discussed when we've been in conversations with people running at the highest scale at those thousands of pounds per day scale, and they're trying to run CRC, like you said, the payoff's almost instantaneous because the volumes that they're of media they go through are just massive.
Mm-hmm. So even for operators that are at a smaller or a craft scale, this equipment does have a space in your craft operations. I think that it can't be emphasized enough that the alternative approaches to color remediation and Dewax have substantial downsides when it comes to product quality. So if your sole focus is staying at the top of the quality in your market, being the top shelf on every retailer's shelf, and gaining an advantage that's going to be difficult for any other operators to gain other than by implementing this technology, using the Dewax and the HTE separation on HMS is an amazing way to preserve the original profile of the flour that you're processing and bringing that into your oil with essentially no other quality sacrifices, unlike you might see with other approaches.
Yeah, and to discuss specifically, if we're not even talking about vape cartridges, if we're just talking about direct dabbable products, I'm going to go ahead and defend the assertion that if you run this oil through the Dewax membranes and just take the Dewax decolored oil as it comes out and use it as a dabbable product, that's going to make a better product than if you had just CRC'd the same material, because you didn't lose any terpenes. You actually increased their proportional amount in the extract without changing any of them or modifying any of their levels compared to each other. You're going to have a better profile for fragrance and a better dabbable experience.
And frankly, let's talk about the retailers, the buyers at retail, and the customers themselves looking at top shelf product. Any increase in the potency that you can get on your dabbable products while still maintaining a high percentage of terpenes in your test results, that's going to give you an advantage on the shelf. It just is the case. Whether from a quality of the experience side, that's always true. That is the way that the buyers are behaving. And in this case, you get both. You get a very good dabbable experience, smooth, consistent vapor. You're not getting any of those waxy effects that you might get from something that hasn't been dewaxed, but you're also getting that pristine terpene profile, all the flavor and fragrance that you're looking for from processing high-end flour. So really, it gives you all the advantages and with essentially no downside. So for top-end producers, this may seem like the scale is too large for you, but the value proposition of maintaining that tip-top shelf, even in flour, processing flour that has all the character you're looking for, but may, for whatever reason, be producing a darker oil.
Yeah.
This will allow you to just take that concern out of your mind, focus on the quality of the fragrance, the aroma, the flavor of the flour, and just have confidence that out the other side, you're going to get a nice golden oil, perfect, pristine terpene profile, and a great dabbing experience.
Yes, definitely. And for an example of some of the output colors, I would look at SciPhy's Instagram, where they posted some Dewax decolor results showing the great improvement. And you can't really reveal it in an Instagram post, but if there was a scratch and sniff, you know the oil also had a proportional increase in its odor quality.
Absolutely. Well, Zev, this has been an amazing opportunity to dive deep with you on the HMS. Thank you so much for joining us here on Plants to Plants Cannabis Processing Talks. And once again, an outstanding interview. Thank you so much. And thanks as well for working hand in hand with us as we brought this product out to market. I can't be, could be more thrilled to be able to bring something that provides so much value out to our clients in the field. And really, I think once this gets out into the wild and people start using it, the evidence is going to be insurmountable that the value here is just unbeatable.
It was very exciting to finally get to this product after years of people asking me when I was going to be able to do butane, and it was always just I'm going to get to that once you know everything else is perfect is developed, and I have some extra time, and I did, and it's been a lot of fun working on this project with SciPhy as well.
All right, well, thanks again. You can find us at SciPhy Systems on Instagram, on YouTube, at any social media platform, www.sciphysystems.com. I'm Emmett McGregor, your host of Plants to Plants and SciPhy Systems CEO. Thank you once again to Zev Feinstein from Molecular Forces. You can find him molecularforcesllc.com, at Molecular Forces, or at Magister Chemist on Instagram and other social media. And please join us for our next episodes in 2024. We have an amazing lineup and can't wait to share more innovation, technology, and cannabis industry trends with you in 2024.
Thanks for having me on, Emmett. It's a great show.